Exercise 319 is very similar to exercise 318. It asks you to identify which compound is more acidic of two that they give you, and crucially, to explain your choice. And you'll explain your choice using these REO principles. So, we have lots of hydrogens in these molecules that can come off. One hydrogen in each of them is on oxygen, other hydrogens are on the carbons. So, between the hydrogens on the oxygen and the carbons, which will be more acidic? Well, the explanation for that would have to do with electronegativity. Now the rule is that if you have two atoms in a row, the hydrogen on an atom further to the right is more acidic. That's the rule, but that doesn't explain why. Carbon and oxygen, those are in the same row on the periodic table. Carbon, nitrogen, oxygen. And as you go to the right on the periodic table, electronegativity helps to stabilize negative charge. So you'd want to include that in your explanation. And so you know that it's the hydrogen on the oxygen that's going to be the most acidic. But that ties in the two molecules. So then you'd want to consider resonance, the next factor. And you'd want to mention that when the hydrogen leaves, it would leave behind a lone pair that would participate in resonance for both of these structures, because the lone pair would be one atom away from an atom in a double bond. In other words, it'd be allylic. And so that spreads out the negative charge. So you'd want to mention that. But that would happen equally in both compounds. So you'd go to the next factor, induction. And for induction, you would notice that these molecules have chlorines. Both of the molecules have chlorines the same distance away, sort of 2 atoms away from where the oxygen is that would have the negative charge. But one of the atoms has more chlorines. The chlorines use their electronegativity to pull the charge toward themselves and spread it out over more bonds, over more atoms. And that helps to stabilize the charge. Because the molecule on the left has more chlorines, the negative charge is spread out over more atoms. And so, the more you spread charge out, the smaller the charge is in any individual place. And so the more stable the charge is. So you'd want to include all of that in your explanation. And you'd end up with the result that that is the more acidic molecule. It has a hydrogen here that's more acidic than any hydrogen on the other molecule. So we followed that third rule, that the hydrogen that has the most electronegative atoms, the closest to it, is the most acidic. And we can use that same rule for B in this problem. In B, you have a very similar molecule. The hydrogens on the oxygens are going to be the most acidic because, unlike the hydrogens on the carbons, the hydrogens on the oxygens leave behind a negative charge that can be better stabilized by the electronegative oxygens. The oxygens will pull the negative charge close to the nucleus. If you have a negative charge with electrons and a nucleus, they'll pull that closer to the nucleus, and that proximity, that closeness to the positive charge helps to stabilize it. Oxygen is better able to do that than carbon because of its electronegativity. So we know the hydrogens on the oxygens will be the most acidic. Both of these leave behind resonance because if the hydrogen leaves, the electrons in the bond between the hydrogen and the oxygen will be the lone pair that has a negative charge. That's allylic to a pi bond. And so that'll help spread the negative charge out over 3 atoms in both of the molecules. But that ties here. And so the third factor is induction. Both of the molecules have just one bromine on them. But the molecule on the left has the bromine 2 atoms away from where the negative charge would be. And the molecule on the right has the bromine 3 atoms away from where the negative charge would be. And so the negative charge on the left would feel the pull of the bromine more than the molecule on the right. Because the further you get away from the bromine, the weaker its pull becomes. Because the pull would be stronger in this molecule on the left, the negative charge would end up getting spread out more, getting spread out more effectively. And so the molecule on the left would be more stable. So that's the explanation that you'd want to include. And that would make this molecule on the left more acidic than the molecule on the right, because it has a hydrogen that can leave behind a negative charge that's more stabilized than any negative charge that would be left behind by the molecule on the right.